Welcome to an episode of Jay Leno's Garage. Today, automotive royalty, the McLaren W1. This, of course, the successor to the F1 and the P1 McLaren. Before we go any further, let me give you some of the specifics. 1,258 horsepower, 988 foot-pounds of torque, and it weighs approximately 3,000 and change pounds, which is pretty light. In fact, I was so impressed, I bought one. And I'm going to find out about it here today, just like you are. Please welcome Michael Leiters. Michael, come on in. Good to see you, my friend.
Thank you.
Thank you so much for making this trip. I can't tell you how much I appreciate this, because you're the guy everybody wants to hear from. You know, a lot of times I say we always get these marketing guys, and they've studied a bunch of press releases. That's right, Jay. It's the number, you know. Whereas you've been involved with this thing since the beginning, haven't you?
Yes, absolutely.
Yeah.
So that's absolutely a pinnacle of McLaren, and I really feel privileged to work on this so important program and car.
And what is your engineering background?
I'm a mechanical engineer. I'm a car enthusiast from my childhood on.
Right.
I always loved cars. I always loved supercars, super fast cars, and yeah, it's actually absolutely my core in my heart. To work on supercars.
And you've had experience driving F1s as well, correct?
Absolutely. I had the pleasure to drive F1s, a very special one also, the F1 LM.
All right.
The special version for the Le Mans celebration. Fantastic car, and even if you sit in this car today, it's still an icon of the automotive history, and it's so emotional, so engaging. It's really a benchmark.
So let's talk about this, the W1, and of course the P1. I love that P1. To me, it's the ultimate car. You know, when they come out, they had what they call the Holy Trinity. You had the Porsche 918 and the LaFerrari.
LaFerrari, yeah.
Which just the law part knocks me off. I'm sorry. It's just like, I don't get the law part. But fine cars in their own right. But I like the Porsche, but having a Carrera with rear-wheel drive and the light power steering, you know, you just don't get that with the Ford. I mean, 918 is a wonderful car, but to me, this was just more visceral. I could have more fun on the road. Mm-hmm. I am not a race car driver. I don't pretend to be a race car driver. So to me, this is the most fun, because getting on the exit, I can kick a little bit and get it sideways and just have a great time. And I imagine this kind of follows that same ethos, right? Rear-wheel drive only.
Absolutely. The briefing for this car was the real supercar, and a real supercar for us means, on the one hand side, performance. But if you think about that, today you can get performance everywhere. You can have an electric car with 2,000 horsepower, whatever.
Right.
Acceleration on the straight is fantastic. But that's not all, right? It's about emotion, engaging. On this car, we have taken some very important decisions. One is, even though we have 1,275 PS on this car,
right,
it's all rear-wheel drive.
Right.
So, and to manage that needs a lot of know-how, because control is very important. Otherwise, you can't enjoy your drive. But to manage that and to bring that all together, that you can really enjoy and feel one with the car, even though you have so much power, that's for our engineers was a big challenge. But driving the car is fantastic.
Well, the thing I like about the McLaren is I drive a lot of supercars, and a lot of times people build a car with a variation of a standard American V8, but with just incredible horsepower and torque and noise, but it's not smooth. I like the scalpel, like you're cutting it with a, you know, one of those Ginsu knives where each shift is that precise. Exactly. It's almost hard to explain unless you experience it, and that's the difference for me with the McLaren and some of the other cars. Plus, the other thing is also the aero. I mean, we've gotten engine management to the point where we're in thousands of horsepower these days instead of hundreds. So then you move to the next thing, which is aero. And this has active aero at the front as well, correct?
Yeah, it's an active aero at the front. On the rear, we have a very special element and feature, which we call the active Longtail. You know, we have the Longtail,
right,
to have better aerodynamics. But on this car, this is a mobile element, aerodynamic device, which we can extend.
Right.
And then we extend actually the diffuser we have in the car.
Right, so you're literally just taking it back so the air goes over there.
Exactly. And that is very important because we didn't want to have a car which is overloaded with aerodynamic devices. But what you see on this car is that the whole shape of the car is driven by aerodynamics, right? And one key element of that is that we have an underfloor effect like in the Formula One. Okay, so you see that the air is going underneath the car and it's expanding under the car, like with this weight it has, and comes along to the end, and this creates a lot of downforce, up to 1 ton, 1,000 kilograms downforce. So there's a lot going on, and this gives you again a lot of control. And
well, I guess the idea is to get the air to move through the car as smoothly and as swiftly as possible. Even more important that it's smooth, because not smooth would slow you down. So
exactly. If you have disruption of the airflow, that creates drag, and you want to create very clean downforce, not increasing also the drag. So aerodynamic efficiency is very key to develop this car. This is like something like an S-duct, and this is a deviator to control the airflow. But the actual piece we have, which is active, is this one, which is flipping. And you see that also here, right? And there are different modes of the car. So when we go on a racetrack, we want this transforms to a beast. Okay, it goes lower, and then the aerodynamic devices get really active, and this the active Longtail extend, and everything gets looks like a real track car.
Right.
If you go in normal mode, everything is fine, smooth. We have the air brake at the end, so we're using the wing for braking and controlling a little bit downforce, but not as extreme like in race mode.
How noticeable would that be at speed with that? Does it really?
It's almost 3 times more downforce than in normal mode.
Right. Okay. This I don't recognize off my other McLarens. This is new suspension, isn't it?
There's a new suspension system, again derived from Milan concept, push rod suspensions in the front and in the rear, again to lower also the car by 35 up to 35 millimeters. And these are active suspensions, so it's very important. If you have so much downforce, you have to have a really rigid car and setup. Then you go on the road, you want to enjoy yourself. It's easy, it's more comfortable.
Well, let's see how that rear tail works here. We can activate this wing remotely, which you can't do you can do it inside the car, but since this is a prototype. Activate that, let's show how that works.
Now it's a long tail,
right?
Okay, and now all this surface we can use to create more downforce without disrupting the flow of the air and increasing the drag. So that is why we call it active long tail.
Okay, and how much force is down on this?
So if we go now and then the maximum force, the maximum downforce is 1,000 kilograms, and in the normal stage you can have around 200, so it's 5 times more. So
that's like people just pushing.
Exactly.
I mean, I can't imagine how strong this must be. Now, how does that work? When you develop this, do you develop metals that, that bends, not strong, that's exactly it? You know, I mean, how many test pieces do you go through?
The testing today is very virtual, so you make simulations. You build up a model in the computer for these pieces and for this force, and then you dimension the pieces. You use the best material, lightweight versus rigidity and stress. I mean, you have to consider also this has to work not only once. We are going, I don't know, 100,000 miles in a life of this car, so we have to ensure that it's working always.
And that's literally like 5 huge men forcing it down.
Absolutely.
I mean, it's hard to imagine because it doesn't look that strong. Obviously, it is.
No, it's holding. It's working.
But whenever I see people put a wing on the back of the car, they go, it's going to break. It's going to.
But the materials today are so good, and really, so engineering is so precise today, so that's possible.
Now, when you're on the road with this, if you're on the racetrack, I come around a corner. I've got my downforce up to force me in the corner. Does this automatically go long tail when I get on the straight?
Yes, so and it can still flip.
Right.
So it will help you to have the right position in the position in the situation.
So I can do it manually, or
now you actually, yes, you can do that, but safety is always overriding your choice.
I see.
So if there's a critical situation, like an ESP system, right? You come to a critical situation, it will override your wish.
So if the car senses that there's still way too much downforce, it won't activate until I'm.
Exactly.
Oh, that's fascinating.
Yeah. No, it's
it's
working a lot, this system.
See, that's what I like about McLaren. I like the science of the technology. It's just, like I said, it's like a scalpel. Just, you know, I meet so many cars that are just bigger, heavier, overpowered versions of the old car.
Yeah.
Whereas with McLaren, it's always, like this engine is only 243 cubic inches. I mean, that's the size of most six-cylinder cars in America, and yet you're getting this tremendous amount of power. It's a V8, yeah, just pretty amazing. Okay, so and when you turn the W1 off, does this automatically go back to reset, or can it stay out longer?
Yes, this goes then back in the default position, which we had before. But again, you can, let me say, provoke and control that, and park the car also like that. So a little bit of show effect you need to.
Yeah, I don't want to provoke it. I want to get it mad. Yeah, okay. Now this piece here, obviously it's an exit for heat. We have a similar piece on this, but this is some...
This is always very challenging because the air is coming in here and washes out all the heat here. But I mean, the turbo, around the turbo you have 1,000 degrees Celsius.
Well, okay, so you're making way more heat even than the P1, because this just has two exits here, you know.
Yeah, and you see also, these are a little bit less sophisticated also how we conduct the air. So, and then one of the worst situations can be if you park then the car and all the heat is still in there, and you don't have this washout effect anymore.
Okay.
So and then you have to make sure that the heat is actually coming out.
So this is some exotic alloy here.
Yes,
obviously.
absolutely.
Okay.
Yeah.
All right, very cool, very neat, very neat. And this piece here.
Yeah, this is actually, and I think again, what this increases is an aerodynamic device which is combining another function. Today you have all these antennas on the cars, so this is integrated here and covered actually, but the main function is an aerodynamic function, again to optimize the flow here and the washout effect in the
I see. Now see, I thought it was a scoop like on the F1, but it's not. This is just to channel the air into to bring it together and
to bring it together and then
pull heat out
over the
rim. Oh, very good. All right. Well, these are not that. These are gullwing door. What do you call them?
These are unheated doors, and the reason for that is again aerodynamics.
Yeah.
If you have butterfly doors, for example, you have a hinge here, and this area is very, very important for the aerodynamic flow. So we have now the center point of the movement for the door is now here.
Right.
So and then the airflow can go very easily around the car.
I like the glass panels here.
That's nice. The visibility in this car is incredible. Yeah. That's always, I think that's a very special point, unique on McLarens, and that makes it also so easy to drive the car.
And this becomes a structural piece as well, obviously.
Yeah, that's structural. Actually, it's a pity that you can't see that, but one uniqueness of McLaren is always the carbon fiber top. And we developed a totally new top for this car here, which is the core of the car. We call it an aerocell, because as I explained before, it is already preparing this diffuser effect, the underfloor effect of the car. But then there's also, we don't have seats, so we are sitting directly in the top.
Right, okay.
And everything is around the driver, so you can move the pedal, you can move the steering wheel, everything comes to you then, and you are like a cocoon, right? You're sitting there and you are really connected to the car, which is so important to control it.
So this, I guess, would be the third cell. I mean, you had the first cell, which was the MP412C, and a variation of that was used on subsequent McLarens. Then you had the P1, that was the second totally new cell, and this is the third.
It's actually the fourth.
Oh, the fourth.
We have already on the Artura, we have a new generation. And this is now for supercars. This is a different technology, more bespoke and craftsmanship in that, less automated, but even lighter. I'm saying it's a core because it's the foundation, like
Right.
the foundation of the car, right? The more rigid you get the top, you can save so much weight on the rest of the car.
Right.
So that's so crucial then for building up this car.
Because remember, when they built the F1, they bragged that it took 2,000 hours to make the cell.
Oh yeah, okay.
And then you got to the 12C, it was 90 minutes. And I don't know what it was. And now this is probably...
No, this is
Still.
because on these cars it was, as I said, more automated.
Right.
I think today it's
But more complex, too.
absolutely.
Yeah. Let's take a look inside, see how the doors work. Well, you get in a bit different than my P1. Let's see. I guess feet first. All right, here we go. Oh, yeah, I like this.
Yeah, you're totally direct connected.
Yeah, I see what you mean. You're sitting in the tub. It's kind of like my 53 Hudson Hornet. They're below the chassis. It's a good step-down design, but you know, very comfortable. And your feet are slightly elevated because that's for the aerodynamics, as you
Yes,
said.
exactly.
Yeah.
Almost a racing Formula One position,
Right.
but still very comfortable.
Right. And the steering wheel, obviously adjustable.
Yeah, exactly. And you see the whole screen
I see.
and the binnacle is
Yeah,
coming with you.
Oh, I see. It comes forward or back. Here we go.
And here you can choose for the powertrain.
Right.
You can go in manual for the gearbox.
Right.
And here's suspension.
And it shows how old my P1 is. There's no rear screen. Isn't that funny? It seems it's so common.
Yeah, today you have to have it. You have to,
Yeah, very nice. And you have the usual sport, race mode, track mode, whatever.
Exactly, and specifically for this car now, because it's so different between going on a race on a track and on the road, we have the mode here, the race mode is called, and then the car is lowering down at the front 37 millimeters, and the wing comes out at the rear, and so on.
So race mode is the new track mode.
Exactly.
Yeah, there you go.
Yeah.
Very nice. Okay. Steering wheel's a bit different.
Yeah, that's for visibility, especially. So one is visibility, and the other one is ergonomy. That you come in easily, you can come into the.
I like the
top.
absence of buttons on my steering. I don't like a lot of buttons on the steering wheel. You just have, what do we have here? We have
One is for aero again
Aero,
to have the manual effect on the rear wing,
Right.
and this is to pass. So here you get extra power for limited time to have an overboost.
Now, when I hit aero, do I keep my finger on it all the time until, or you just touch it and it goes to full
you touch
aero?
it and it goes there, and it shows you here on the display
Okay.
what is the position of the wing.
Gotcha, okay. Again, this is a prototype, so this is not a working model. This
Not
is like a
exactly.
design model, more or less?
Yeah,
Okay.
it's a design model to show what is the rough functionality and how it feels like. But now we are testing already in our proving grounds the car and do the, let me say, last fine-tuning and ensure affordability and reliability of the car.
And does this have an activate button like I have on the P1? You know, to...
It goes always to default, and you can directly go on these commands and controls to select the right mode.
And behind me, these are, is that your storage?
Yeah, exactly. So if you
There you
probably
are.
not if you're sitting into
There you go. There you go.
but if you get out, you can flip them and then
like if you take a trip and you want to bring a toothbrush, well, it'll fit right there. You put the toothbrush right there, maybe a little get the small tube of paste, and you're all set to go. Yeah. You know, if your wife won't let you get a motorcycle, this is the perfect vehicle, guys. I'm telling you, it really is. This is the way to go. You can carry more in the motorcycle, but this is going to be more fun and be faster. Yeah, so that's your luggage area there. All right, very nice. And this material, what is this? It's not leather, it's not Alcantara.
This now is in Alcantara, but there's another version of that. We call it InnoNet, which is a nightwear.
Yeah.
We have developed specifically for us.
Yeah.
And it's very smooth, and you don't see any inlays for speakers and
Oh, I
stuff.
see. I like the tires right here. That's pretty amazing.
Yeah, that's cool if you can look into the tires, and not only on the tires, but also actually into suspension. And we have additive manufacturing on the levers for the suspension. so laser melted pieces,
Right.
to have it really lightweight and has a very innovative
Is that a
technology.
first for McLaren, push-rod suspension in the front?
Yeah, it's the
cars?
first one that we have that on a road car, this technology here, right?
It's not electric steering, hydraulic?
No, it's another point. We have this unique feeling, and we decided to have still an hydraulic steering.
Right.
And also the brake is hydraulic, is not brake by wire.
And what disc brakes? I know that has the, what, Akebono, is that how they say it?
We have Brembo here,
Brembo's here?
Brembo set up here, and yeah, that's very performant and very, very, very good.
Interesting. Very nice. Let's see, is this open here? No.
I think here it's open. There's only a little.
More storage. There you go.
That is really for the toothbrush, right?
Oh, that's for the toothbrush.
That's for the toothbrush.
Yeah. Okay. Well, it's a very, very comfortable place to be. I got to admit that. It certainly is nice. And as you said, the seat does not move, but pedals and brakes.
Yeah.
And of course, adjustable foot pedals. This is again a prototype, so it doesn't have any of that. This is just a design thing to give you an idea what the car looks like. And the motor is not operational, so we're not. Sadly, we can't drive this one, but we'll drive one very soon.
Oh yeah, we would be happy to have you and do a test drive.
No, I think it's very exciting. I just love the science that goes into this and the technology. It's just fascinating, because if you're one of those people like me, OCD, say, yeah, everything's got to be perfect, and it's just great. I like the way everything is laid out. It's right in front of me. I like that this. You know how many cars, when you adjust the steering wheel blocks either the speedometer or other gauge, it drives me crazy. So if I want to be able to see, I can't see that.
Yeah.
I like the fact that you've trimmed it here, and even on its full, even all the way down, it's not blocking the speedometer and the information. That's great. You know, I see other supercars with all the buttons, and they seem so overly complex. Whereas this is just a nice, clean sheet design. It seems to have everything all those other cars have, just laid out more sensibly, which is what I like. Okay.
I think it has to be always easy to drive a car, right? Not too complex. So I think that's.
Yeah, I mean, these windows here are really what make it, because when that was the thing about the P1. It's a real greenhouse now. It's bright and airy inside, just because the windows are clear, you know. And the reason they do those windows that way is because of high-speed pressure. Isn't that correct?
No, it's more about the structure. In the case of crash.
Yeah.
So the doors taking also a lot of loads from the crash impulse. So that is more the reason that we are doing that.
And you've got F1 technology here in this.
Yeah, this is very particular material.
This is a massive frame rail here, isn't it?
Yeah, but you need that for the side impact, right? You need that. And again, the car is weighing only 1,399 kilograms. Mm-hmm. So it's super light, but very, very stiff and rigid.
And this is approximately 3,000 pounds, something?
It's 3,084 pounds, so
pounds.
Really light for the power you have and as a hybrid car.
And that is light, because you think you've got to have all the safety equipment. You've got to have the steel door guard beam, but this doesn't have
No, we don't have that, Jay.
Yeah.
We have all carbon fiber. So the engineering of these doors and the whole thing, and also the carbon top is so rigid only by carbon fiber. We don't need any additional beams or.
Now, normally when you design a car like this, you design it, and then you go back and you put the big steel chunk in there, the guard, the crash door. Material, but you don't have that.
No, we don't need that. So all is thought in from the beginning, and the material or the door itself, but also all the top is so rigid and so precisely laid out that we don't need that.
Well, I just like that they're world cars now. They can go to almost any market in the world, can't they?
Yeah. We have a one world car, right?
Because that is a big problem in the States. Couldn't go overseas because it didn't meet their standards. Theirs didn't meet our standards. But now you can have anything anywhere you want it, which I think is great. All right, let's see. It's very cool. Again, I just love being able to reach out here and pull a nail out of the tire while I'm in the car. You know, that's fantastic. You fix a flat while you're in the car. You just pull it out, stick the thing in, boom. Yeah, I'm really anxious to drive. It seems very visceral, having the tires and everything. I mean, literally right here. There's no wasted space on this thing. And it's quite a small car that has full-size room inside it. Because I'm 6 feet tall, and I'm very comfortable. I mean, I have the seat, I have the pedals moved a little bit forward, so there's even more room for somebody much taller than I, so that's not a problem.
I think our engineers are very good in package efficiency,
Yeah.
right? To bring everything very compact together. That's also important to have a very nimble car, to have the center of gravity and the inertia in the right place, and yeah.
And you move these seats closer together for center of gravity also, don't you?
And lower, especially,
And lower,
right?
yeah,
You-
yeah.
We call it H point, so your hip point,
Right.
as low as possible, that you feel really sink into the car.
Yeah, I mean, I actually kind of like having my feet slightly elevated because, not that there's a great strain on my ankle, but you're not, one thing, you're not sitting off to the side like you are in a lot of cars. And second, you can sit straight ahead. Oh, it's great. And this is some thinner glass too, isn't it?
Yeah, all the glass is optimized,
Right.
that it's very light.
So no safe light repair, safe light replace with this. This is that glass or plastic? It's glass.
No,
right?
glass, it's
yeah,
glass,
It's
yeah,
glass.
yeah.
Right. Is there a bit more room here? I know it's in the P1 we're more like this. More
Yeah, but
closer
again, the package efficiency of our engineers allows us now to have a little bit more space for
Right.
our shoulders, to have more comfort.
Okay. And the airbag is moved, it's not in the door anymore.
No, it's in
Or-
the thorax here, and
it's
that
in
again
here.
gives us also some
Yeah.
space and better comfort.
This is kind of like my 55 Gullwing Mercedes that has this big,
Yeah.
right here. Yeah, that's funny, yeah. See, things never change, some things. All carbon, isn't it? Is there any steel in this thing at all? I'm trying to
No,
think.
we have some steel, but
Yeah.
the whole structural parts are, all structural parts are with carbon fiber.
Let's talk about some of the design elements. Was it important to take cues from previous McLarens, or do you like to go clean sheet all the
No,
time?
I think one, the car is very much shaped by the aerodynamical functions we have on the car, but it's very important. You know, we're talking about the one car lineage, so we wanted to have elements from F1, P1, also on the W1, right? And one specific point on all McLarens is the sink-in cabin. So a cabin which is actually thinking into the fenders, and you're sitting then in the cabin also very low, like you experienced before. Then a very specific point is, we call it performance line, where you have the fender and then you are going down actually to this point, and then the rear fender starts already. But this lower point here on the performance line is actually for visibility. If you drive, you want to have a free view to the side, right? And that defines its two fenders and then this low point here on the performance line. Yeah. So that is very important. And then what you can see on this car, which is very particular, I said about the aerodynamics which are shaping this car, the side pods, they look actually like a Formula One car.
Right, well, it does. I guess the idea being the more heat, or more power, the more heat, and the more heat, the more cooling. So you just got these.
Exactly, and it's so important. So you have two main streams of air. So one is underneath the car, the airflow underneath the car for the downforce effect, and then you have the side on the side where the flow is going around the car to cool down the heat in the engine.
I know you did away with the sort of nostrils on the front. Is
Yeah.
it more efficient this way?
Yeah, that's actually to have the best cooling in the front for the car, and then a smooth airflow over the cabin.
Right, yeah. So obviously just going what works best as opposed to
Exactly.
what else. You know, so many manufacturers are kind of stuck with something because the customer expects. You know, a Corvette went from the round tail light to the square tail. Oh, it's not a Corvette. Oh, Corvette guys went crazy. You know, you can't change anything. You know, the 911. I mean, it came in with the engine in the middle is actually a better handling car, but you're stuck. You've got that ethos of, you know, the engine's over the axle. Okay, you know, I like the fact that you just go with what works. I like the fact that I can see the suspension here through, and this is also for cooling too. It's not merely for that.
Yeah, exactly. So also to bring the cool out, the heat out from the car. But for us, it's always important that actually the function defines the design, and then it gets to a timeless design.
You know, when you were talking about the cooling, obviously I live in California. I go out in the desert, it's 110 degrees. I've never had any of my McLarens even get hot. I mean, maybe 205, 210 is about as Fahrenheit as you can, and that's normal.
Yeah.
You know, so I've never had any cool, and like you say, the cooling is very important. This has more cooling than any car
Yeah,
you've done
and
at this
we
point.
changed also the concept. So the
Right.
high temperature radiators are sitting now in the front on this car, the first time on a McLaren. So for us, obviously, that's also very important that you can have in every condition the full power of the car.
Michael, thank you very much. I know
Thank you
this
for
is
having me.
a huge deal getting this here. As we mentioned, we're not driving this because it's not drivable. This is a prototype. That's why everything isn't exactly as it should be, because they haven't started production yet. But they'll start, I guess, in January of 26?
We want to deliver the first cars in first half of 2026.
2026. Well, I will be in that first half. So there you go. That's pretty good. I'm excited. Michael, thank you very much. And well, I hope you understand why I'm such a fan of this marque. You know, I've been involved with it since the beginning. I was there when the 12C came out, and it was fun to do that. You know, I grew up in an era, I was great friends with Dan Gurney and Phil Hill and Penelope Jones, all these guys, and they talked about how going to visit Mr. Ferrari when there was a little building, and you know, Phil Hill raced for tires and for gasoline. I thought, oh, I got free tires. I won the race. I got free tires. You can get $20 million. But it was an exciting time, you know. When McLaren started in 2010 with the Woking and all, I was at the beginning, and I've been through it all the way through. So it's fun to get the holy trinity, you know, get the three cars all together. So I'll let you know as soon as that happens, you will find out about it. Michael, thank you very much, my friend.
Thank you, Jay.
And thanks everybody at McLaren to all the effort it took to get this thing here. And I hope you enjoyed learning something about the W1. See you next week.